All right, problem number 8 here. We've worked a few of these in the first video. Problem 8, we're given the concentration of ammonia, and we are given the Kb for ammonia. And from this, we're asked to do the pH. And again, this works if the concentration of the acid is significantly larger than its dissociation constant, then this equation is true. (3.84 times 10 to the minus 3. I'm going to go straight on to POH. So minus log of this number, still have it in my calculator, minus log of the previous answer, 2.42, and then pH is going to equal 14 minus 2.42. (7.58). This next one, again, not a calculation problem, but it is a descriptive kind of problem, and it says which set is a conjugate acid conjugate base pair. Okay, and a conjugate acid conjugate base pair differ. Conjugate acid conjugate base pair, those differ by a proton. Okay, you take the conjugate acid, remove a proton, you get the conjugate base. Take the conjugate base, add a proton, get the conjugate acid. So the only one where this is true is B. Okay, for B, H2PO4 minus and HPO4 2 minus, those differ by a proton. The one that your eye may be drawn to is C. Those actually differ by 2 protons. It takes 1 proton to make hydroxide into water and a second to make water into hydronium. So those are actually not a fair conjugate acid conjugate base pair. Number 10 here, oxygen and ozone are allowed to come to equilibrium in this exothermic reaction. What change will increase the numerical value of the equilibrium constant? And there's only one thing that changes a rate constant, and there's only one thing that changes an equilibrium constant, and that's temperature. Okay, one thing in the entire universe. Okay, none of those other things do, only the temperature. Okay, what the other things can influence is the position of the equilibrium. So you're going to have the same equilibrium constant, but as you mess around with the reaction, you may have more product relative to, well, that's not true. The reaction may have to proceed in one direction or another to maintain the equilibrium constant. And so in this particular one, which factor will affect both the position of the equilibrium and the value of the equilibrium constant? And again, that would be lowering the temperature. Lowering the temperature will favor products, but it also, since it's a change in temperature, will affect the equilibrium constant. Okay, and then number 12 here. So Kc equals Kp only when reactant moles of gas are equal to product moles of gas in terms of how many of them there are. Okay, so if we look at that first reaction and notice, and when I did this today, I glanced right over this. So in 12A, the first reactant, 2A, it's a gas, but B is a solid, C is a solid, and then D is a gas again. And so in A, we started out as with reactants as 2 moles of gas, and we went to 1. So Kc is not equal to Kp here. For B, we went from 2 moles of A to 2 moles of D, so the number of moles of gas are left unchanged, so B is the correct answer. Let's just go ahead and look at C while we're talking about it though. For C, 3 moles of A go to 2 moles of D gas, and so again there's a change in the number of moles. So this is only true for B, for option B. Okay, 13 here, this is going to be being able to look at a balanced equilibrium reaction and write the equilibrium expression. Is very helpful for something like 13 here. So I'll rewrite my reaction. Equilibrium reaction. Yep. Okay, and this equilibrium reaction, so Kc is equal to the concentration of, this is ethane over ethene or ethylene times the concentration of hydrogen gas. So it is products over reactants. And so if there is a lot of product and a little bit of reactant, then Kc is very large. And that's the case here with number 13. It's a huge number, so there's almost no reactant left and there's a lot of product. So it would be the product is greater than the concentration of the reactants at equilibrium. Okay, here for 14, I'll just rewrite this. I will put in my state symbols now. P4 plus 6 Cl2s is in equilibrium with 4 PCl3. Okay, this species is a gas, this one's a gas, this is a solid, so this doesn't contribute to our homogeneous rate constant, equilibrium constant. And so Kc is equal to PCl3 raised to the 4th power from this 4 right here over Cl2 raised to the 6th power. And so that would be answer letter C would be the correct answer.